And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is solve the Sudoku, which is marked as a hard level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given one matrix of 9 by 9. Okay, so number of rows will be 9 and number of columns will be 9, and it will be containing the elements, the numbers from 0 to 9. Okay, all right. Row is total rows are 9, total columns are 9, and the value can be anything from 0 to 9. Okay, all right. And basically we have to solve the Sudoku. Okay, and basically when we will change this matrix and like it will be containing those elements which make the Sudoku solve, we will just return, because as you know, key matrix is passed by reference, so it will be accepted in the parent function of here, and we will check there if Sudoku is correct or not. Okay, so this is what we have to do. We just have to solve the Sudoku. Okay, now many of you will be knowing what is Sudoku and many of you will not be knowing. Okay, Sudoku or Sudoku, what it is, I is confused. Okay, so whatever it is, and many of you know, many of you not know, but if you not know, let me show you what is Sudoku. Okay, all right, so let's go to one note here. So basically you can see this matrix we are given. Okay, and here the elements which are greater than 0, like 3, like 6, like 5, like 7, their positions are filled. Okay, these positions are filled automatically and we cannot change them. Okay, now those positions which are 0, it means these are empty and we have to fill any element from 1 to 9 in these positions. We can fill any element only between 1 to 9 in these 0 0 positions. Okay, all right, but what's the criteria to fill these? It's very exciting. Look, if I want to fill one here, let's suppose I want to fill one here, so one should not be present in that row. Okay, one should not be present in that column. Okay, and one should not be present in that 3 by 3 matrix. In this 3 by 3 matrix, one should not be present. So three things are there. First one, not in that row. Second one, not in that column. And third one, in that 3 by 3 matrix also it should not be present. Okay, now your question will be key row and column we got, but what's the 3 by 3 matrix? Okay, so basically we consider this in Sudoku, we consider these as a blocks, sub blocks. Like this is one block, this is one block, this is one block. In this way we have 9 blocks, 1 2 3 4 5 6 7 8 9. Yeah, 9 blocks. Okay, so suppose if I'm filling at this position, then also we will consider this 3 by 3 block. If I'm filling at let's suppose at this point, then also we will consider this 3 by 3 block. If I'm filling this 0, so I will consider this 3 by 3 block. If I am filling this 0, then also I will consider this 3 by 3 block. Okay, so basically 3 by 3 some matrix we have divided, and if current row, if current cell is falling in that matrix, we will check in that matrix, in that 3 by 3 matrix, if that element is already present or not. Let's suppose if I am filling 8 here, so can I fill it? First of all, I will check that row. So no, in that row we cannot fill it. Okay, so let's fill something another. Uh, let's suppose I try to fill 6. Okay, 6. Can I fill 6 here? In that row it is not present, but in that column it is present. In this column it is present. So we cannot fill 6 as well. Okay, all right. Can I fill 9 here? Let's see. So for 9, it should not be present in that row. Correct. It's not present in that row. 9 is present in this column. No. 9 is present in this submatrix. Yes, 9 is present here, so we cannot have a duplicate 9, so we cannot fill 9 here as well. Okay, in this way we have to fill one by one all the elements at each positions where 0 are there. We have to try to fill these with empty, I think you guys are getting, with empty things, with empty whatever it is, and we have to return the correct Sudoku. So the correct Sudoku will be like all the 0 positions are filled, all the 0 positions are filled, and they are valid as well. Valid basically means in all the zeros which we are filling, that element should not be present in that row, in that column, and in that 3 by 3 matrix. Okay, all right, I think I have already explained like a good amount of what is Sudoku, so it will be very clear now. And now we will move on to approach one by one. Okay, all right. First approach is basically to check if I can fill 0 here or not. Oh no, not 0. If I can fill, I will start at any 0 I will get, I will start from 1. So can I fill 1 here? Yes, I can fill 1 here. Okay. Now, why I can fill? Because 1 is not present here, 1 is not present here, and 1 is not present in this matrix as well. Okay, I can fill 1. Now, 1 is filled here. Okay, now I will come move forward in this row wise, in like first 0th row and columns now will move. I got this 0. Okay, so can I fill 1 here? I will always start from 1. Can I fill 1 here? No, because 1 are collapsing. Okay, can I fill 2 here? Let's see. 2 in that row is not present. 2 in this column is also not present, and 2 in this 3 by 3 matrix is also not present. So yes, I can fill 2 here. Okay, now I move to next cell, which is 0. This is this. Can I fill 1 here? No. Can I fill 2 here? No. Can I fill 3? Let's see. On filling 3, it is not present. It's present in this row. So we cannot fill 3 as well. Can I fill 4? Yes, I can fill 4 as well. No, I cannot fill 4 because 4 is already present. Can I fill 5? 5 is also present. Can I fill 6? Yes, I can fill 6. On filling 6 here, I will move to the next row here. Again, I will check 5, 6, then 0. So I will again start from 1. Can I fill 1 here? Yes, I can fill. No, I cannot fill because this one and this one are in the same matrix. This one and this one, they are both in the same 3 by 3 matrix. So they are duplicate. I cannot fill 1 here. Okay, in this way, we will keep on checking and filling. And whenever, let's suppose, I have filled few things. Ki, yeah, I have filled few things and now this is last 0 and I cannot fill any element in this from 1 to 9. There can be cases when I cannot fill any element from 1 to 9 here because either they are present in this row, either they are present in this column, or they are present in this 3 by 3 matrix. So if I cannot fill either of the elements, I have to backtrack. I have to backtrack. Like I have to now, let's suppose I filled 4 here. So now I have to backtrack and change this as well. Currently I was here, but now I'm not able to fill anything. I will backtrack here. And now again, I will try to fill this with some other element to check if I can fill here, but still if I cannot fill, so like 1 to 9 I have to check, and for let's suppose for this 1 to 9 values I am not able to fill this 0, so I have to change its earlier errors like this. Again I will start from 1 to 9 here and then change it, then check if I can fill anything 0 here, then again I move to here. So in this way it's a total backtracking way to solve this, because there is no algorithm still developed to solve it. We have to try all the cases, we have to try all the possible ways of filling them for all the integers from 1 to 9, and if we can fill it I will move to the next thing. And suppose I filled it 1 here or anything here, let's suppose I filled it 7 here, so now I will move to the next row, I will move to the next row here. Again I will try to fill from 0 to anything, all the elements, and if I'm able to fill, again I will move to the next row in this way. But if at any point I'm not able to fill any element from 1 to 9, I have to change its previous key cell, I have to change its previous cell. So now for all the 1 to 9 in this previous cell, again I am not able to fill this, so I have to change its previous cell. So for this, the previous cell will be this. Okay, in this way we will keep on checking and filling, checking, filling, checking, and at last if I come out to the row 9, if I come to the row 9, because we are 0 indexed, so 0 and 8, if at any point I come to 9, it means I have filled, it means I have filled all the Sudoku with valid entries, and now I have got a solution. I will simply return. Okay, because now my grid contains the solution, and in the parent function it will be checked and we get our answer. I hope this explanation will be very very clear to you. Now I'm going to write the code, and with the code I'm going to explain it step by step so that it becomes more clear to you. But before that, let me quickly tell one more case. Look, when I have to fill any element, let's suppose I am filling it here, or let's suppose I'm filling it here. Okay, if I want to fill 5 here, so I can very easily check if 5 is present in that row. If yes, I have to change it. I can also check very easily if 5 is present in this column. But now how can we check if 5 is, if this entry which I'm trying, let's suppose 5 is present in this 3 by 3 matrix, is present in this 3 by 3 matrix? How I can get? Look, if at somehow I can get the row and column number for this 0, I can simply make a loop for I is equal to 0, I is 3, and j is also plus 3. We will run a loop and traverse all the elements one by one. Okay, all right. So how can I get to this point? How can I get to this cell? That is very, very interesting. Similarly, for let's suppose this 0, I have to get the row and coordinate of this position, so that after coming here I can easily check ki yaar I plus 3 tak chala do, and j column is there, so j plus 3 also column. We will run the loop and check if that number is already present or not. So how can I get these coordinates? How can I get these these, because this is what we need. Okay, all right, let me quickly tell you, very, very easy it is. Suppose I am at this point, so my row number is what? My row number is 0 1 2 3 4 5. My column number is what? I think column number is 7. Okay, all right. So what I will do, I will just do row number 5 divide by 3 multiply by 3. We just have to remove the reminder. We just have to remove the reminder so that I can get our answer. So basically 5 divided by 3 is what? One quotient is there, and 1 into 3 is 3. So for this, 0, my starting row is 3. Starting row is 3 means starting row is this. Okay, and what will be my starting column? Again 7 divided by 3 into 3, which is equal to what? Which is equal to 6. Okay, so 6th column is basically this column. Sorry, 6th column is basically this column. So this is the cell from where row is equal to 3. I will run a loop. I is equal to 3. I is less than 3 plus 3. C is basically j. So j is equal to 6, and j is less than 6 plus 3. J is less than j plus 3 or 6 plus 3. Anything you can do, and check if in this whole matrix my current element is present or not. I hope this point will be very, very clear. We are just taking a multiple. So until this point my column, my starting column will be this. But if I'm coming here, my starting column will be this. Okay, similarly, uh, till this point my starting row will be this, but when I come to this 0, my starting row will be this. In this way, we are going to do check with this RC and simply run a loop. I hope I have already explained this enough, and it will be very, very clear to you, like how I'm going to approach the problem, what algorithm, what solution we are using. We are simply using backtracking to try and test all the ways. Okay, all right, now let's quickly move on to the code section and write the code of it so that it becomes crystal clear to you. All right, now let's write the code. But before that, if you have loved the explanation till this point, if you have loved my dedication, please subscribe the channel and like the video, because it will really motivate me a lot. And yeah, I've made a cool Chrome extension for you as well, with which you can watch the solutions here only, instead of moving to lead code, instead of moving to YouTube and solving it there. Okay, so make sure you try that as well. Let's quickly move on to the code section. First of all, what I'm going to do, I will simply make a solve function which will solve my thing. Okay, so here first of all I will pass my matrix. I will pass, currently I'm at 0 row and I'm currently at 0 column. Okay, all right, now let's quickly make this function as well. Static boolean, we are going to use boolean here. Why, I will tell you. Solve, and it's basically int of matrix, and int r current, and current, let's name it as I and j. Okay, basically current row, and basically which cell I'm currently at. I'm filling this 6, I'm filling this 7, so basically it is that. Okay, all right, now if at any point, if you remember, I told okay, if I my row number, if my row is 9, it means I have filled all the rows of Sudoku, so I will simply return true. Okay, all right, so if I is equal to 9, basically I'm hard coded it. You can also use mat.length, because but here it's written, it's always equal to 9, so I'm just using 9. Okay, all right, and I will simply return true. True basically at any point means if we can fill it, we have filled the whole. thing. Okay, all right. Now, one more thing we have to do. So basically, let's suppose I am currently at this point. I am currently at 1. So 1 is already filled. So I will move to this. I will move to this. Now again 5 is filled. So I have to move to 9. Again 9 is already filled. I have to move to 8. Again 8 is already filled. So I have to move to 7, because look, these are the fixed values. We cannot change them at all. Okay, all right. And after that again 7 is also filled. So I move to 9. How I'm tracking this? Let's quickly see this. So very easy it is what I'm doing. Let's find out next I and j. So int next I is also equal to, let's suppose, 0 for now, and next j is also equal to 0 for now. Okay, all right, very good till this point. So if my j is equal to 8, it means j is equal to 8. It means currently I'm at this column, 281753, this column. So now after moving there, I have to make my increment my row, and column will be 0. Okay, I think you guys are getting why I'm doing this. So simply next I is equal to I plus 1, and next j is equal to 0. Okay, all right. I hope, why? Because now I move to the first column of next row, because I'm currently at the last column. Okay, otherwise very simple it is. Next I will be same as I, and next column will be equal to column plus 1, or it will be j. I'm using j, so j plus 1. Okay, all right, we are very good till this point. Now look, in what case I have to fill this, uh, fill any of the cell. In which case? In the case when it contains 0, then only I have to fill. But if at any point my matrix of I, what I'm writing, matrix of I j is equal to, is not equal to 0, it means it is already filled, and I will move to the next element. So what will be the next element? Simply use return solve. Now we will basically solve for the next cell. Next cell is basically matrix, and I have already calculated next I and next j. So next I and next j, we will simply use them. Okay, all right. But if it is 0, so we have to fill this cell. We have to fill this cell. Okay, all right. So how I am going to fill? I have already told, we will start from 1 till 9. 1 till 9 we will simply go. So for int I is equal to 1, I is less than equal to 9, I plus plus. And now what I'm going to do, I'm going to check if I can fill I as 1, if I can fill I as 2. If yes, I will move to the next. But if I cannot fill, I will simply try with another number. Okay, so let's suppose if is valid. This is a function which we will be making in very soon. So is valid is a function, and it is accepting what? My current matrix, my current row number, my current column number, and the value which I am filling. So if we can fill this, so let's quickly fill this. Basically, if it is a valid value, so now I am trying to fill. So matrix of I j is equal to val. Very good till this point. And now what we will do, I will move to the next row. I will move to the next cell. Cell is basically any of the 1 2 5. Here you can see these all are cells. Okay, so how I will move to the next cell. Basically call this solve function again with matrix and next I next j. Okay, if solve matrix next I next j, and now if this is also filled, we will simply return true. Okay, basically return true means it is filled. Okay, all right. But if we are not able to fill with any number, so what I have to do, I have to backtrack. I think we can write it here. Else we will backtrack with matrix I and j is equal to 0. Okay, all right. Now this for loop will keep on going, and if at for any value of I between 1 to 9, I am able to solve this whole Sudoku. Now look, I'm calling for the next row. I'm calling for the next cell, and then next cell will call for the next cell, then that next cell will call for next cell. In this way, 7, then 4, then 8, 6. Again, I got 0. I will fill anything. If we can fill it with anything, I will again move to 1, 2, 5. So with after coming to the last row, this new row where I'm returning this true. So then this true will return to this 0. Then this will return true to 1. Then with 3, then 6. So in that way, I will come at any point here. So basically it will keep on returning true for all the cases, something like this, and then I will come here. Okay, so if I am coming here, I am checking here if I can solve, return true. But if I cannot solve, I will mark this as 0 and move back to the previous row, previous cell. Okay, all right, so in this way we are going to do. I hope it is clear. Let's quickly use this. And now look, if I'm coming out of this for loop here, it means if I'm coming at 69, it means we cannot fill any value from 1 to 9, and now we have to backtrack. So how I'm going to backtrack? Simply return false. Because look, if I'm again saying, if I'm returning false for this 0, it means this 2 is fixed, this 7 is fixed, this 4 is fixed, now this 0. So I have to try changing this 0 value. Like suppose it was 5, it's currently 5. I will now try to make it 6 and again check with all the Sudoku numbers. If it is not saying so, I will again move to 7. Now try 7 here. But in this way, if till 9 it is not valid, so I have to again backtrack. So these are the fixed numbers. In this way, I will again backtrack, fill that cell with next number, again move forward. In this way, we just have to do. Okay, all right. I hope it is very, very clear to you now. And at last, I will simply return false. So yeah, that is it. And now we just have to complete this is valid function. Okay, let's quickly complete this. Static boolean is valid, and it's taking what? Int matrix, int r, int c, like basically current row and current column and its current value. Okay, all right, let's quickly see if how can I can fill this. So basically first thing is I will simply check for the row and column. So just run a loop for int I is equal to 0, I is less than 9, I plus plus. Okay, if matrix of ith row and c column is equal to val, or matrix of r row and ith column is equal to val, simply return false. Returning false here from is valid function means I cannot fill this is valid is false. So this if condition I will not go inside them, and now I will change this I value to the next. Let's suppose if it was 4, I will again try this with 5. So it will become 5 now. Let me quickly name it as val. I don't know why I have written this I. It will be val because I is already used. Okay, so in this way we are going to check. All right, so this row and columns are done. Now I have to check for 3 by 3 matrix. Okay, so for that, let's suppose starting row is equal to what? If you remember, row r divide by 3 into 3, something like this. Okay, and similarly I will do for str column. Starting column is equal to c divide by 3 into 3, and we are just taking the numerical part. Okay, all right, let's quickly run the loop now. For int I is equal to str starting row, I is less than starting row plus 3 I plus plus, and same thing I will do for the column. Let's suppose j starting column. Guys, I hope you guys are with me till this point because it's a bit long video, but believe me, it's a very, very cool solution. Okay, so again, if matrix of I j is equal to val, it means this value is already present and I cannot fill it, so simply return false. Okay, all right, but if I come out with 88 line, it means it is not containing in any of the row and column, and it is also not containing in that 3 by 3 matrix. So we will return true here, which means now we can move forward. Okay. All right. So yeah, that was it. It's a bit long code, but I have already explained it bit by bit. So it will be very clear to you. And now let's try to submit this. Let's see if I have not done any silly mistake. So yeah, I've done one silly mistake. It's next C. I've written it should be next J. Okay. Let's write it next J. And I'm also see one more error, which is this. It should be I plus plus, and here I should increment J plus plus, not I plus plus. Okay. All right. Let's try to submit this again. Meanwhile, if you have loved the explanation till this point, please subscribe the channel and like the video because it will really motivate me. Download the Chrome extension as well, and let's try to see if it is getting accepted. Yes, it is getting accepted. So I hope you have loved the explanation, and I'm going to see you again tomorrow. Till then, keep on coding, subscribe the channel, like the video, and bye.